Okay, we've added the plane for the front plate, so I guess we'll do a sketch. This is pretty easy because we'll just project through the outside of the robot, plus the top and bottom from the motor mounts, and then draw a rectangle. We did 3 and 4 points to it. What I might also do is draw the probably screw these motor mounts in. So probably do some mounting holes for it, which will just be 2 holes, 2 screws for each plate. I'm going to draw a construction line between each hole, just to make it so I can constrain it so it's around the center line and everything like that. So I make these construction lines parallel to that. They're vertical now. And then make the center horizontal to the center. And now equal around the center line. And then I make those equal. They also make the hole sizes equal. Wonderful. How big should we make these holes? What size screws are we using? I don't know. We'll make them 5mm. We can change that later. The distance from the edge is the chopping board thickness divided by 2. And over here, chopping board thickness divided by 2. And we'll make them 50mm apart. Now I've got to do some over the other side. So I'm going to draw another construction line from that hole across, and then down, and then from the outside hole across, and then up. And then if I make these 2 construction lines equal to the construction lines on the opposite side, those holes are vertically exactly the same as those holes. And then if I make the center point of this line vertical to the center point of the robot, and the same for the bottom, the ends of those lines are now exactly on the opposite side of the robot to those ones. So I can put in these 4 holes, and I know that their positions are exactly opposite. I don't know if I did that too fast for anyone to understand or not. I mean, you can do it any way you want. As I always say, you don't have to copy what I do. Everyone does it a different way. As long as you end up with the right result, it doesn't matter how you do it. There's my 4 holes for mounting screws. So I'll finish that sketch. Name it front plate. Done. And now we'll make a back plate. So we'll just project a plane from that one, select the back corner, there's a new plane, turn the visibility off, name it work plane rear plate, make a new sketch, and so far our rear plate will be exactly the same as the front plate, so we'll just project through everything from the front plate. We don't need to redraw anything, and both plates are exactly the same. Done. That one and that one. Finish sketch. Rename it to rear plate. Done. Save. And we might as well create the front and rear plates now. Standard part, new, scroll back down to simple, very simple here. Open the skeleton, turn everything off, select front plate, select chopping board thickness, done, extrude, the other direction, chopping board thickness, okay, my properties, physical, HMW white, apply, close, save as frame F003, save, copy, next, new part, derive, find where simple siding, open, turn everything off, select the rear plate sketch, select chopping board parameter, extrude the distance of chopping board parameter, okay, change the eye properties, physical, HMW white, apply, close, save, F004, 004, save, okay, copy that part into the assembly, paste, close it, open the other one, copy, assembly, paste, and also close all these parts I've got open. Again, go to the eye properties for that part, occurrence, set to 0, 0, 0, apply, grounded, apply. I always go apply before I hit grounded, sometimes it chucks a wobbly. If you've got one constraint, bug it up. It doesn't like sticking it in there. Anyway, occurrence, 0, 0, 0, apply, grounded, apply, done. Ooh, now we've got something that's looking like a robot. Pretty ugly robot. Pretty simple too. That's what you wanted. Ooh, I can see I've made a mistake. My holes are in the wrong spot. That's a pretty dumbass thing to do, isn't it? Well, go back to the sketch, front plate sketch. I know what I did wrong. I dimensioned from the wrong side. I'm going to delete that dimension. See the holes on the other side are not constrained anymore. Shift across. Put the dimension back on. Save. Make the dimension the same as this one over here. Done. All good. Finish. Save. Go back to here. Hit the update button. Holes are in line. And the back plate as well. Oh, I love top down. Now we can screw this thing together. Fun. If you click on the design tab at the top, the first one is the fasten button, which is the bolted connections. Bolted connection. You've got types, you've got a through connection or a blind connection. You use blind, so blind are like screws and whatnot. What size screws are we using? I'll do 5 at the moment. Select the start plane, which is the front plate. Select a hole. Select what you're screwing into. And if you look at it from sideways and zoom in, you can see that Inventor's going to drill and tap a hole into the rear part. It saves me a lot of trouble of doing that myself, because an Inventor would do it the right size and match the bolts. Or screws or whatever we're using. I don't know what I'm using actually, I'm just doing this for fun. And if anyone ever makes this freaking thing, they'll probably end up using wood screws or something, so it doesn't matter what size holes and things I'm using at the moment. Come on, let me check a screw. I want a screw. I need a screw. Thank you. Category bolts, hex head bolts, X-head flanged bolts, socket head bolts, round head bolts, square head bolts, countersunk bolts. Let's go for round heads. Nothing really looks like a screw anyway. Inventor doesn't really like screws. It prefers bolts and things. We'll just go for a round head. Button head Allen key bolt, M5. It automatically chooses a good length. So it says 16mm will work there. And as you can see, it probably will. If we increase that plate thickness to like 20, it'll choose like a 30mm long bolt or whatever. And it's only putting one in, so we'll select the circular reference button again and select all our other holes. And it will do all 8 holes and screws and everything for us. Apply. Now you can change this name if you want. If you got a huge assembly, you might want to change that name to something, but because it's my robots and my computer, I leave it the same. Yeah, those are my screws. Actually, we should have put washers on those. Edit design. Bring that back up. Click this little bar, it says add a fastener. Click it again. Computer thinks for a second and brings up the washer menu. So you can choose a washer. We'll just go for the first one. Just a tiny little machine washer. Okay. There we go. Now we've got screws and washers. I mean, in real life, we're probably going to use wood screws. You won't really use washers on those. Maybe you will, maybe you won't, I don't know. Doesn't really matter. But there we go. We're screwed. We'll do the back. Start. I'll do this a bit quicker if I don't talk. I'll draw slow when I don't talk. No, when I talk, I draw slowly. You guys are slowing me down. Come on, hurry up. Done. Bolts on the back and in front. Awesome. Now I guess we do the outside plates. I'll save my video first.